Okay, so 7A is all about radian measure. So I want you to think about if we are dealing with the unit circle, the radius is just 1. Typically, the circumference of a circle is always 2 pi times the radius. So in a unit circle, that means that all the way around is 2 pi. So radians are to degrees, just like centimeters are to inches. It's just a different way to measure angles. So think about when we go all the way around a circle, we always start here where this is 0 degrees. This is your 90 degrees because that would be a right angle. This is 180 degrees, 270 degrees, 360 degrees. So if we want to see what that is in radians, all the way around the circle is the circumference. So that means 360 is the same as 2 pi. So let's think about it. All the way around the circle is 2 pi. Halfway around the circle is 1 pi. So that means 180 degrees is the same thing as pi. So then half of pi, a quarter of the way around the circle, is pi over 2. And then 270 is halfway in between pi and 2 pi, so that's like 1.5 pi, but we always rewrite that as an improper fraction. I think the hardest part about radians is understanding that halfway around the circle is 1 pi and all the way is 2 pi, but it's because of the circumference formula. All right, so then if we want to just convert back and forth without graphing it, we're just going to use the relationship that pi is 180. So if it's in degrees, you're going to multiply by pi over 180 to turn it into radians. If it's in radians, you multiply by 180 over pi to get degrees. So we're just going to use t-charts. If you want to convert 45 degrees into radians, we put pi on the top, 180 degrees on the bottom, because that cancels the degrees out. So we have 45 pi over 180, but 45 we can reduce. 45 over 180, that's just 1/4, so it's pi over 4. Say that we have 126.5 degrees. So if we have a decimal that doesn't reduce nicely, we still need to have degrees cancel, so that's why 180 is on the bottom, pi is on the top. You're just going to use your calculator, take your 126.5 and times it by pi, then divide it by 180 times pi divided by 180, and you're just going to round it to your 3 sig figs. So that's 2.21. Then to go backwards, we already have a fraction built with 5 pi over 6, so just extend your fraction bar, create a crossbar. Since pi is on the top, we're going into degrees, that's why degrees needs to be on top. This will be our unit left. When the pi is in it, it's real easy because it just cancels. I always see that 6 goes into 180. We can divide that and get 30 degrees times 5 is 150 degrees. So think about that. If this is a whole pi, 5/6 is somewhere over here. That's 150 degrees also. So same thing if you don't see the pi. Oops. But if we're going into degrees, we always need degrees on the top, pi on the bottom. You always just multiply going across, divide by pi, get your decimal, 3 sig figs with your degrees left over. All right, that's the end of A. Then for B, It's just two formulas with arc length and area of the sector. So your arc length is just that piece on the outside of the circle, and they use L for length, which then it's hard, it looks like a 1. Sometimes I'll make a cursive L. So there's two sets of formulas. This is the degree formula, and then this will be the radian formula. So I just put both formulas together. The degree formula is super annoying because you end up putting pi over 3 or theta over 360. Notice theta is just the angle measurement. The radians is so much better to deal with. It's just literally the angle times the radius for the arc length, and half of theta times the radius squared for the area. So I think there's just two problems for this. Okay. So this is in radians, so make sure you're using your radian formula. Check and see if that's in your formula booklet, because that might be handy. So arc length is just the angle times radius. So the angle is in radians, 3 times 12 is 36. And arc length is just a singular unit, just use centimeters. Area is 1/2 theta r squared. So theta is our angle measurement, radius is 12. So just multiplying it all out, we get 216. Our unit is centimeters, and because we're doing area, it's squared. And that's going to be because your radius is squared. So the last example gives you the radius and the arc length. So you're going to work your way backwards. We always will use the radian formula unless it says it's in degrees. And sometimes I would just change it. If you get degrees, I just convert it into radians and then use the radian formula. Just easier. So we know that the arc length formula is the angle times the radius. So I can replace the arc length with 12.3. I can replace my radius with 8.2 theta, solve for theta. We get theta to be 1.5 radians. A lot of times we don't even use the label for radians, we just leave it as 1.5. But now that I know the angle, we can find the area. Plug all that into your calculator. Round it to 3/6 figs. And this is in centimeters and area squared. And that's it.